Hello, Dr. Burke, and welcome to Group 13's video presentation of the design concept. The design that we picked is going to utilize two servos, a power amplifier, a DC motor for height adjustment, and various tubing for our firing mechanism. The reason that we came up with this idea and picked it over the four others was that, first of all, we found it to be cost-effective without sacrificing quality. The materials that we were able to choose have been proven to be durable. For example, we're going to be using PVC piping, but also we're going to be able to position our robot and move it without sacrificing any unnecessary cost. Because we are using 3 signals from the Q4 board, we're going to have 2 pulse width modulations and 1 analog output. We're able to modify all 3 dimensions of the position at the same time. Other designs that we had, they were a little too complex to control on a multi-functioning basis. So this was one reason why we chose this design. The other thing is that, as I stated before, we are going to use closed loop feedback to modify the height. This way we're meeting our requirements, and also we are adjusting something that will be easy to do with closed loop feedback. The measurements and the physical limitations that we have calculated also led to us picking this design. We foresaw various problems with balancing with some of the other designs. We saw various problems with closed loop design with some of the other designs, and just overall functionality in the other 4 designs. And this design was a compromise, but we thought that it was a compromise that fit best to all the necessary requirements. So now Mitch will take you through the design concept.
Hey, Dr. Bird. I know you can't really see our presentation right now because we don't have a big screen and we're not in Lowry, but you'll have a copy of this and hopefully I can run through a bit of it with you right now. Our ping pong robot on the level 0 has 3 main inputs, which are pretty simple. We've got our image acquisition, which will be coming, of course, from the cameras you've set up in our lab, and then connected into our XPC target computer. We have our software that we'll be writing to adjust many things based on the image that we'll be acquiring from the camera, which will be adjusting the aiming of the robot, the firing mechanism of our gun, etc. And then, of course, we have our power supply. Our image acquisition will be coming through our camera into XPC target, as I said, and then going into our Q4 board, which will be outputting 2 pulse width modulation signals and an analog output. And the 2 pulse width modulation signals will be controlling our servos, like we did in the second project. They'll be controlling the rotation and the pitch of our gun. And then the analog output will be sent through an amplifier, which will be using a transistor to make into a DC motor, which will be used to adjust the height of the scissor lift, which we'll be using to adjust the height. And we'll just have our motor attached to a screw on the scissor lift to adjust the height when that is necessary. And one of our main advantages to using these 3 signals is that they can all be used independently. And so hopefully that will gain us a time advantage over other groups' robots, because we'll be able to adjust all 3 dimensions at the same time. Now, the firing mechanism should be coming through our Q4 board as well, and we'll just go straight to our compressor, and then into the regulator, and through a hose into our gun, which David will explain right now.
So our gun makeup is going to be a hose that goes into a pressure chamber that then goes into a blow-off valve and then to the barrel. The reason we decided to do this is that we wanted to make sure that we have a good streaming flow of air. So that's the reason for the pressure chamber. And the reason for the blow-off valve is if there was any fault with our regulator, the blow-off valve would recognize it and would release the air pressure. Therefore, we wouldn't overshoot or undershoot the ping pong ball, making it accurate. We found this to be a low-cost solution. We found that it wasn't going to be very heavy, and therefore it would also fit in well with our design. And then after going through the blow-off valve, then it will go into the barrel and then it will fire. Another big reason of the blow-off valve is that safety is a very important part of this project, and we didn't want any mistakes if we were to sell it to kids and they were pointing it in the wrong direction or pointing it at the eye of somebody else, that the ping pong ball would not accelerate to a point of being dangerous or being harmful. So therefore we have this blow-off valve, which we thought was a key concept. That about wraps up our presentation. Hope you enjoyed it, hope you understood it, and if you have any questions, we're available.